Hi, welcome back to example 2 from 1.6, determine a quadratic equation given its roots. So in this example, we want to determine the exact equation of a quadratic function. So it says here, find the equation of quadratic function with given zeros and containing the given point. Express your answers in standard form. All right, so for part A, we have our two zeros, 2 and negative 2, and we must contain the point 0, 3. All right, so these are actually quite easy to do. I have a nice process for doing these. So for part A, what we're going to do is we're going to take our general form for a quadratic. Okay, remember this is the general factored form. Okay, and remember R and S represent the zeros. Okay, or the x-intercepts. So in this question, we are given the two zeros, R and S. We're also given a point which gives us a value for x and y. So we know that, and it doesn't matter which one goes where. Like I know we have 2 and negative 2. It doesn't matter which one goes in for r or s. Either of them can. So what I'm going to say here is, let's call this one r. Let's call that one s. Okay, it doesn't matter which one. And then in our point, obviously those are going to be x, y, right? 0, 3. So in my next line, I'm going to sub in r, s, x, and y. Okay, I'm going to sub all four of those things into this equation. Okay, and if you're wondering, well, what's y in this equation? I know x is here, but well, if you remember, f of x replaces y, right? F of x just means y. So let's go ahead and let's do that substitution. Okay, so we will have f of x is y, so I'm going to plug 3 in for f of x. I don't have anything for a, so I'm going to leave that. I'm going to plug in 0 for x. For r, I'm going to plug in 2. For x, I'm going to plug 0 in again. And then for s, I'm going to plug in negative 2. All right, so what you can see here is I have everything plugged in. The only thing I don't know is a. That's my only unknown, which is kind of nice. I can now solve for it. So we have 3 equal to a times negative 2 times positive 2. Okay, 0 minus a negative 2 becomes just 2. So we have 3 equal to a times negative 4, right? Negative 2 times 2 is negative 4. I can divide out that negative 4 on both sides. And we can say that a must be equal to negative 3 over 4. Okay. Now that I found a, I found my parameter that's going to give me the specific member for the quadratic that will have those x-intercepts and also go through that point. So I just kind of determined the unique quadratic that fits those x-intercepts and goes through that point. So we're just going to state it. We'll say, therefore, f of x is going to equal negative 3 over 4. And I'm going to plug my zeros in. So we'll have x minus 2. And then the other one was x minus negative 2, which when we write minus negative 2, we know this is actually just going to work out to plus 2. So this is now the exact equation. Okay, however, I believe the question asked for it in standard form. So this is the exact equation in factored form. So why don't we go ahead and distribute? That way we can put everything in standard form. Okay, so we'll have let's just write it out real quick, and then showing the distribution. We'll worry about the negative 3 over 4 later. So x times x is x squared. X times 2 is 2x. Negative 2 times x, negative 2x. And negative 2 times 2, minus 4. Okay, notice this is like a difference of squares setup. X minus 2 times x plus 2. The middle terms cancel. So you might have recognized that. So I'm just going to show the cancellation of those two. And then finishing this up over here, we would have negative 3 over 4 times x squared minus 4. And now I can distribute this part in. Negative 3 over 4 times x squared gives us negative 3 over 4 x squared. And then now negative 3 over 4 times negative 4. So we're going to end up with a plus. And if you're not sure, if you want to write it out, 3 over 4 times 4, you can see that the 4's will cancel. And we're left with just 3. So we can say, therefore, f of x is equal to negative 3 over 4 x squared plus 3. That's our equation in standard form. Okay, so that was the first one. Okay, we got 2 more to do. Each one's going to be a little bit unique in terms of the information that's given. Okay, I'll just need to compress this. Okay, so looking at this next one, it says we have a double zero at x minus 2, and it contains the point 310. So if we have a double zero, it just means the zeros are repeated. So that means R and S are both equal to negative 2. So R and S are both equal to negative 2. And we still have our X and we still have our Y. Okay, let's start this right here. So we'll start with our general factored form. So our goal is to try to figure out what A is to make this equation unique, right, to the family. So we're going to plug everything we know in. So we can plug in 10 for Y. Let's do that real quickly. X is 3. So we'll plug in 3. We have a double zero at negative 2. So we're going to have a negative 2 here. And then we have the second one is the same thing again. So we're going to have 3 minus another negative 2. Okay, that's showing a double zero of negative 2. So we have 10 equals A. I have 3 minus negative 2. It's 3 plus 2. Okay, which is going to work out to 5 in both of these brackets. So we have 10 equals A times 25. We're going to divide out the 25 on both sides. And then we'll leave this as a fraction. We can divide 5 out. And we can say that A must be equal to, this simplifies to just 2 over 5, right? If we divide both of them by 5. So 10 divided by 5 is 2. 25 divided by 5 is also 5. All right, so we have A equal to 2 over 5. I could then use that to write out my general equation. And however, I do need to put it in standard form. So let's start with this here. 2/5. So notice here, like x minus r, when we plugged in our r was negative, and we end up with like a positive 2 here. So I can rewrite it when I put it in here. I can write it as x plus 2. Okay, that shows a 0 of -2. We know it's repeated, so we could write it as squared, or we could just write it out again like this. Okay, I'm writing it that way because we do need standard form in this question, so we're going to have to do FOIL, right? We'll worry about the 2/5 later. We're going to have x squared plus 2x plus another 2x plus 4. We have x squared plus 4x for the middle term plus 4. And now we'll just have to distribute this in. I'm going to write my f of x back in here because this will be our final equation. 2/5 times x squared is 2/5 x squared. Then I'm going to have to multiply this by the 4. So we're going to have plus 2 over 5 times 4x. And then we're going to have plus 2 over 5 times 4. Okay, our final line. So this isn't going to really clean up nice. We're going to have 2 times 4. That gives us 8. So we'll just have 8 over 5x. And then our last term will be 8 over 5. Okay, and that is our final equation in exact form. Okay, and this equation, it satisfies all this criteria. It has a double zero at -2, and it contains 310. Okay, so if you were to put -2 in for x, this will all work out to 0. And if you also were to put 3 in for x, you should get 10, okay, because it contains the point 310. Okay, I'm just going to compress this one, and then we'll go ahead and do our last example.